Hello and welcome to my channel. I am BeardedDev, bringing you another SQL tutorial, and today we're going to be looking at like. So like allows us to search for a specified pattern. Now there are a few symbols we use when working with like. There's the percentage symbol, which can represent 0, 1 or multiple characters. Underscore, which represents one character, and then within square brackets we can actually pass in a character list. Now it's also worth noting that like can be extremely slow, so be careful when using it. It's not good to have likes within stored procedures or anything that's going to be automated or used in production. We're going to head over to SQL Server Management Studio now, and we'll work through some examples. We're in SQL Server Management Studio. I've just simply done a select all from our customer sample, which has got 1,000 customers in here. If you haven't seen how I've created the customer sample from a full table of approximately 2 million records, do go back and check out my creating a sample set of data video, and I'll also leave a link to the description. A link to the video in the description below. But for the purposes of this video, we're going to be looking at like. So like's always good to have a look at names of customers, which is what we're going to be doing in this example. So we'll go ahead and just jump straight in. So it's something we're going to be using within the where clause. And initially we're going to start off looking at the first name. So how we'd normally write a query, so if I was to search for a customer, I'd just write out that within, and then we could go ahead and find out all our customers with the first name of Aaron. But let's imagine we have a scenario where we want to find out all our customers that begin with a certain string. So let's think of these characters as strings, and we're going to look within that string and try and find a pattern. So that's where our like comes in. So instead of having an equal sign, we have the keyword like, which will be grayed out for us. And in this case, if we was to just leave that as Aaron, it would go ahead and return exactly the same result, because we're looking, that is equivalent of just having the equal sign there. But we're going to change this up, and we're going to have a look at any customers where their first name begins with GE. Let's say we're looking for a particular customer, we might have entered his name incorrectly and we need to find out where he exists and update that information. And we're going to have a look at using the percentage symbol first of all. So remember back from the introduction, that represents 1, 0 or multiple characters. So if I just add the percentage symbol there, what that's going to do is search for any customer's first names that begin with GE and then can have any number of characters after that. So if their name was just GE, or if their name was GE followed by 100 characters, they will still be returned with this search. So if I go ahead and execute that now, we've got typical names we'd expect like Georgia and Gerald, and that's returned 6 rows. Another important note was if I was to add the percentage symbol ahead of the GE, that's going to change our search. What that's now going to do is search for any customers where they've got GE anywhere within their name. So if they had 5 characters, then GE, and then another 5 characters, so it was in the middle, they would still be returned. So if we go ahead and execute this now, we can see we've got other results like Angelina and Angel, because GE occurs within their name. And this is where like can become quite slow, because it needs to search all strings to see if that pattern exists within them. If we're just looking for the beginning of the name like we did initially, that is still a valid searchable argument to SQL, and indexing can still be used. If we add the wildcard character percentage symbol at the start, then indexing can't be used and it's no longer a valid searchable argument, but I'll build on that in future videos. For now, it's just important to know that that can be quite slow, so it is dependent on where you insert those wildcard characters. But we can build on that to have it the other way round. So if we want to find first names that end in a certain character string, we could say we could begin with our wildcard character and then we'll just enter NN. So if I enter this and run this query now, we're now finding customers where their first name ends in NN but can have any number of preceding characters. So if I go ahead and execute that query, we've got Johan, we've got Ryan with 2 N's. So their first name ends in NN, so they're returned correctly. And then also when we're working with like, we also have the option of not like. So if we don't want to return the results of customers who end in NN, we can simply add the keyword not before the like, and if we go ahead and execute that now, we receive a large number of results because there's a large number of customers first names who don't end in NN. Like is always good if you're beginning to work with a data set that you haven't worked with. Perhaps you're looking at a product data set within a new company and you want to find out different types of products that have available. Maybe they've got sort of 1,000 products and you want to search at what's available. So you could begin sort of doing some tests with the data, just getting to know it using like. Let's move on now to the underscore character. So I'm just going to take out not. Now if I just put in an underscore character there, that's going to return results where their first name is only 3 characters and the last 2 characters are NN. I don't think I've got any customers that match those results. So typically, I guess Anne without an E would typically be returned there. But if I go ahead and say we'll enter underscore B, so remember underscore only represents 1 character, so in this example we're looking for the second letter of their first name to be B, and then if I enter the percentage symbol, and then we could say there's any number of characters after that result. So if we go ahead and execute that now, typical names we'll get are Abby, Abigail. So the first character can be anything, the second character must be a B, and then you can have any number of characters after that B. So that's the difference between the underscore and the percentage symbol. Underscore only represents 1 character, whereas the percentage symbol represents any number of characters. So what we could simply do is, if we're looking for people who say have got 5 characters in their name, but the second letter's B, we could simply add 3 more underscores, go ahead and execute that, and that will return customers with 5 characters where the second letters are B. And then we could even replace the last one and we can go ahead and execute that. So the 5th character is now a Y and we've got the correct result set there as well. So underscore can be useful just because it represents 1 character, and if we're searching for a certain length then that can be helpful for us, whereas the percentage symbol wouldn't be. It doesn't enable us to search for certain length strings. Now let's have a look at a character list which is passed in within square brackets. So if we open a square brackets and we said where first name like A, B, C, D, and then used a percentage symbol, and we went ahead and executed that, that would return us any customer's name that begin with A, B, C or D. So we're effectively passing in a list of values, and then again we've got the percentage symbol to say have any number of characters after the first letter. We could also add in the underscores to get a certain character length. So there I've added in 3 underscores. So I want any customers whose first name is 4 characters long and begins with A, B, C, D. Again, with all the wildcards we're looking at, we could use the not like, and that would return results that don't match. Now what's even better about working with character strings is we don't actually have to type out the full list. If we're looking at just A to D, for example, we could just write out A, effectively a minus sign to D, to say this is our range search for these characters. And if we go ahead and execute that, we'd expect to see the same amount of results. I'll just take the not off there as well. So we'd expect to see the same amount of results than if we actually typed it out. And again, we can add further and clauses in here with further likes, but again, this is where our performance is going to be affected. So if we was to say and last name like B, so we'll return any customers whose first names begin with A to D that are 4 characters in length, and their last name begins with a B. So we can have multiple like statements within our query as well. Now, what's good about the database engine as well is it can automatically convert different data types for us. So I also have the customer ID column in here. So if I was to look at the customer ID column, I could simply pass in a character list of 1 to 3, and we're going to say it begins with 1 to 3. Now, the customer ID column is set as integer. The database engine in SQL will automatically convert that to a string for us, and then we'll be able to run this like statement. So if I went ahead and executed that now, we could find all customers where their customer ID begins with 1, 2, 3. And then lastly, we'll just recap regarding beginning with a wildcard character. So any wildcard character at the beginning will make it an invalid searchable argument, which means proper indexing can't be used, which is likely to cause slower queries to be executed. So let's say we want to find all customers that don't have an A in their name. So I could change this query to say, we'll change this back to our first name column to make sure we're looking at the correct column. So first name, not like, and then we're going to put in A. Now I'm working with SQL Server, so it's not case sensitive, so it doesn't matter if I enter a capital A or a lowercase a. So if I go ahead and execute that now, we can see names like Bennett, Bentley, Billy. They don't have an A in their first name, so we could run queries like that as well, but again they'll be quite slow. Now you can see my queries have pretty much returned significantly, but if I was to work with a large amount of data, then we would see speed issues. Really hope you have enjoyed that video. I find playing around with like is quite fun. Obviously I never use it within a production environment, so if we had a query that would insert customers data or products data, I'd never use a like within the where clause, not within production. If I'm just looking at data and it's a small data set and I just want to get to know it, then maybe I might want a few queries against it. Or if you're working with a CRM database and you want to find certain customers like we've gone through today, then it can be quite useful, but it's more useful for just one-off queries. And if you are new to the channel, do check out my other videos, subscribe to the channel if you haven't already, and click that notification button to be made aware of when new videos are uploaded. Feel free to post any comments below and share the video if you wish. Thanks a lot for watching.